Hello everyone, welcome to STEM Education. I am Tanvir, your chemistry teacher. So in today's lecture, we will solve IGCSE Year 11 question paper, and it's a recent question paper. You can see it is 2022 October and November question paper. Okay, so paper 1 is multiple choice and it is for code. Now, see, the first question is what? Which rows describes the spacing and arrangement of particles in a solid, a liquid, and a gas. So, in a solid, as we know, atoms are compact together. Okay, atoms are very compact. Okay, in solid, atoms are very compact to each other, and they arrange regularly. Okay, not randomly. So, in solid, particles are close together and regularly arranged. So, first two option cannot be the right one. Okay, it can be either D or either C. Now, in liquid, atoms are far away like solid, but close enough like a gas. So we can see here, or we can say that in liquid also, atoms are close together and randomly arranged. Now in a liquid, atoms are close together, but they are randomly arranged. Close together, but they are randomly arranged. And in gaseous form, they are far away. Atoms are very far away to each other and very random arrangement. So very far away and random arrangement, close together, and random arrangement, close together, regular arrangement. So the answer of this first question will be A. Okay guys, understood? Now we will see question number 2. Which piece of apparatus is used to measure the exactly 25 centimeter cube of hydrochloric acid? So for measuring volume of any solution, we use burette. So the answer of second question is B. Now the third question is very interesting. A mixture contains salt, sand, and sulfur. Now what is given? Salt dissolved in water but not in xylene. Sulfur dissolved in xylene but not in water, whereas sand does not dissolve in water or xylene. So how we can, so what is the order of processes used to separate salt, sand, and sulfur from the mixture? Okay, what is the question? The question asked how we can separate these three, okay, salt, sands, and sulfur from each other. So first of all, we will do, because we know that salt is dissolved in water, not in xylene. So first of all, this mixture I will dissolve into water. I will mix with water, or you can say I will add into water. Suppose I have a container, and in this container water is present, okay, and I added this mixture. Okay, after added this mixture, what will happen? Salt present in this mixture will dissolve into the water, and after dissolution or dissolve, I will filter this. So I will use filter paper. This is filter paper. Filter paper. Okay. And I will take another beaker which is empty, and I will pass this solution over this filter. So what will happen here? Liquid will collected where NaCl is dissolved. In this solution, you can say NaCl is dissolved into water, and it will be this side. And above this sandpaper, above this filter paper, sand plus sulfur will remains, which is known as residues. Sulfur remains. Okay. And this is named as filtrate. This is named as filtrate. So filtrate. Now in second step, what I will do, I will add in this, because this is known as residues. So I will add xylene to this residues. So suppose in this container I have what? I have xylene, and this xylene I will add the residue. Residue means I have sand plus sulfur. So in this xylene, which is soluble, sulfur is soluble. So when I will add this residue in xylene, sulfur will soluble in this, and again I will filter this solution, and I will take a empty beaker, and in this sulfur containing sulfur dissolve sulfur dissolve in xylene will be collected here in this beaker, and above this filter paper, what will remains? Only sand will remains here, sand particles. So that's how we can separate these three mixtures from each other: salt, sand, and sulfur. So what is the order of processes? First, I will add water, then filter, then what I will do, I will add xylene to the residues, and then I will add filter. Okay, and then I will filter this. So overall, the answer of this third question is C. Oh, sorry, B part. Now we have question number 4. What is this? The structure of an atom is shown. Okay, the structure of an atom is shown. Okay, this is what at center nucleus is present, and in a nucleus 9 protons and 10 neutrons are present. Okay, this dot represent electrons, N represent neutrons, and P represent protons. So which row shows nucleons number and the proton number of this atom? So first of all, what is nucleon number? Nucleon number is same as mass number. Okay, and what is the mass number? Mass number is proton plus neutron. So here proton is how much? Proton is 10, and neutron is 10 and proton is 9. So it is 19. So nucleon number or mass number is what? It's 9. And second one is proton number. So proton number is 9 here. So 19 and 9. Answer D. 19 and 9. Answer D. Now, fifth question. Which statement about an alloy is correct? So first of all, alloy is what? It's a mixture. It is a compound made up of two or more element, or one of which is a metal. No, it's not a compound. Alloy is not a compound, it's a mixture. So it's a layer of metal plates. No, this is not the right one. This is not the right one. It's a single. No. When we are saying alloy, we are saying that at least two metals are mixed together. It cannot be a single element. So answer will be C. It's a mixture of metal with one or more other elements. Now question number 6. Which statement about potassium bromide are correct? So potassium bromide means KBr, and it's a ionic compound. So it has a high melting point. Yes, it has high melting points. It dissolve in water. Yes, it dissolve in water. When KBr put into water, it convert into K plus aqueous plus Br minus aqueous. Aqueous means K plus present into the liquid and Br present into the water. Water and water. So it is known as K plus aqueous, Br minus aqueous. So yes, it dissolve in water and it conduct electricity when solid. No, it cannot conduct electricity when it is solid. It can conduct electricity when it is in molten state. So because in solid state, there is no charge separation, there is no K plus or Br minus, and for electricity, there should be charge. But in solid, there is no charge. So option third is not the correct one. Okay. So overall, A is the correct answer, 1 and 2. Now, question number 7. Which rows describe the bonding in graphite and the use of graphite? So first of all, as we know, graphite is what? It's an alloy of carbon and it forms 3 covalent bond with other carbon atoms. And in diamond, there are 4 covalent bonds with other carbon atoms. So covalently to 3 other atoms, covalently to 3 atoms, covalently to 4, covalently to 4. Okay, so these two answers are wrong. Either A is correct or B is correct. So now the second one, it is use of graphite is in cutting tools or as an electrical conductor. So it is used as electrical conductor because as we know that graphite is the only non-metal who can conduct electricity. So as it is used as an electrical conductor. So 7th B is correct answer. Now caffeine is a stimulant found in coffee. Caffeine is a stimulant found in coffee. So this is the structural formula of caffeine. Which formula represent caffeine? So first of all, we need to calculate how many carbons present into caffeine. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5, 6, 7, 8. So overall, carbon is 8. Okay. Carbon is 8. Now hydrogen is 1. Sorry, nitrogen is 1, 2, 3, 4. So 4 nitrogen is present here. And how many hydrogens? 3 hydrogens, 3 hydrogens, 6 hydrogens, 3 hydrogen, 9 hydrogens, and this is 1. So total 10 hydrogens are present here. And after that, how many oxygen atom is present here? So 1 and second one is 2. So C8H10, C8H10 and 4O2. So this is the correct answer. C is the correct answer. Now question number 9. Fuel ethane. Fuel ethane C2H6 burns in air to form carbon dioxide and water. So how we will do this? We can see that 2 moles of ethane requires 7 moles of oxygen molecule and it will give 4 moles of CO2 and 6 moles of water molecule. So which statement about burning ethane is correct? So which statement about burning ethane is correct? So when 1 molecule of ethane burns, 1 molecule of water is formed. No, no. See, 2 moles, it is producing 6 moles. So if we have 1 mole, it will produce 3 moles. So if I have 1 molecule, so it will produce 3 molecules of water, not 1 molecule of water. So this is wrong. The number of atoms at the end of the reaction is the same as at the start. Okay, now we'll see number of atoms. So number of atoms is what? Carbon is 1 atom, CO2 is 2 atom, and if I say H2O, it means here 3 atoms are present. In 1 molecule of water, 3 atoms are present, whereas 2 of hydrogen atoms and 1 of oxygen atoms. So in the same way, here initially what we have C2H6. So C2H6 means C at 2 carbon atoms and 6 hydrogen atoms. So overall 8 atoms, and it is multiplied by 2. So 8 multiplies by 2, 16 atoms. Now this is O2. So O2 is already 2 and it is multiplied by 7. So 2 into 7, which is 14. So this is before reaction. How many atoms before reaction? It is 30 atoms before reaction. And after reaction is 1 plus 2, 3, and 3 multiplies 4, 12. It is 2 plus 1, 3, 3 multiplies 6, 18. This is also 30 atoms. So before and after, the number of atoms remain same. So this is the correct answer. But we can see during the reaction, there is decrease in the number of molecules. No, there is no decrease in number of molecules. You can see that in the right side, there are 10 molecules, 4 from CO2 and 6 from water molecule. And in the left side, you have only 2 molecules of ethane and 7 molecules of water. So overall 9. So this side 9, this side 10. So after the reaction, its molecule increases, not decreases. So this one is wrong. And this reaction is exothermic, not endothermic. This reaction is an exothermic reaction. It's not an endothermic reaction. Now we will see question number 10. Which statement about the electrolysis of concentrated aqueous sodium chloride is correct? So this question is based on electrolysis. Suppose we have like this. Okay. At this point, we have positive electrode, and this point we have negative electrode. So it is positive, so it is connected with positive end of the battery. It is connected with negative end of the battery. So it is known as cathode. It is known as anode. Okay. And NaCl is present here. So NaCl is present here. So it will break down Na plus and Cl minus. So as I already said you that this electrode is a positive electrode. So if it's a positive electrode and this is a negative electrode, so according to this, it is positive and this ion is negative. Positive, negative will attract each other. So left side, what will come? Left side, here Cl come, and here Cl minus come, and here Na plus will come. So this electrode will collected by Cl minus, and this electrode is collected by Na plus. And because it is written as aqueous, so water will also be in this form, H plus and OH minus. So OH minus will go to this place and H plus will go to this place. And now what we can see that at cathode oxidation takes place. Okay, sorry, at anode oxidation take place. At cathode, reduction takes place. Reduction take place. So overall, so when at anode oxidation takes place, so what will happen? Cl minus will convert into so what happens here? Here this Cl minus converting to 0. So overall oxidation number increases. So what happening here? What is happening here? Chlorine is produced at a positive electrode. So chlorine is produced at a positive electrode. So at this electrode, positive electrode, chlorine gas will produced. Okay, and at negative electrode, hydrogen gas will produce here. And what happens Na or NaOH? We will see in the later classes what will happen in this, or you can directly say that NaOH may be formed because Na is remains here and OH remains here. So they may have product like NaOH, but according to electrolysis, what happens? So these, why they do not oxidize and do not reduce? We will see the reason why they not Na cannot be reduced and why OH cannot be oxidized. OH minus cannot be oxidized. So the answer of question number 10 is A. Now, question number 11. When an acid is added to an alkali, temperature of reaction mixture rises. So it's basically a neutralization reaction. We already know this, that when acid react with base, alkali means base. This alkali means it's a base. So when acid react with base, a neutralization reaction takes place, and overall the reaction of the mixture increases. So it's a neutralize, and when it release some energy, we say it's a exothermic reaction. So it's a neutralization reaction, and second one, it is exothermic. It will release heat energy. So now question number 12. Some properties of 4 fuels are shown. Which fuel is a gas at room temperature and makes 2 products when it burns in a plenty full supply of air? So we have 4 fuels like hydrogen, methane, octane, and wax, and this is the melting point and boiling point are given. So we need to find out at room temperature 2 products are makes 2 products when it burns in a plenty supply of air. So see here, if we have methane, so when methane react with oxygen, it will form CO2 and water molecule. Octane can also produce, but it's the lowest at room temperature. It can easily, because as we go, as we increase the number of carbon chain, temperature requires more. See here, it is boiled at 126. Okay, it is boiled at 126, and we need to react at room temperature, which is 25 degrees Celsius. That's why methane is the first group which will make 2 products at room temperature, carbon dioxide and water. Which process is a physical change? Okay, which process is a physical change? So burning wood is a physical change or is a chemical change? Cooking an egg, it's a very confusing example to the student. Sometimes student take this answer that cooking an egg is physical change, because they think before boiling egg was in liquid form, and after boiling it convert into a solid form, so it's a physical change. No, it's not a physical change. It's basically it's a chemical change, because the proteins present into the eggs before boiling, it desaturated, or you can say deform into another proteins. That's why here chemical change occurs. So cooking an egg is not a physical change, it's a chemical change. Burning wood is also not a physical change, it's a chemical change. Why? Once we burn the woods, it cannot be regained to into a its original shape, its original properties. Suppose if I have a piece of wood, and if it burns, it will convert into ashes. Okay, and ashes is lighter in weight than wood. And we cannot make we cannot convert ash into a wood. That's why it's also a chemical change. It's a chemical change. It's a chemical change. Rusting iron, this is a chemical change. But melting an ice cube, it's a physical change. Because if ice is melt into liquid, okay, we can convert this liquid into cube also, or in ice cube, by decreasing the temperature. So this is what, it's a physical change. There is no chemical change. So melting an ice cube is a physical change. Now question number 14. A student adds excess chlorine to dilute hydrochloric acid at room temperature 25. Hydrogen gas produced at and produced is collected and measured at room temperature and pressure. So this is the graph, this one. It is represented by X. This graph, this graph below one. This graph at room temperature. Now, experiment is repeated at 50 degrees Celsius with all other conditions remaining the same. So we are increasing the temperature. So increasing temperature, the rate of reaction becomes faster. So it will go in forward direction. So basically, the rate of reaction faster. So overall, you will see the increase in volume of hydrogen gas, but it will be not very high. It will be moderate. So the answer will be B here. Now, question number 15. Substance Y is a pink solid. When substance Y is heated gently, it becomes a blue solid. And when blue solid is cooled down, it remains blue. And when again water is added, then it is a pink. So we can directly say that if we heat, it changes its color, and after adding water, it takes its original color. So we can say that, or we can take an idea that the compound should be hydrated. Okay, the compound should be hydrated, either hydrated cobalt 2 chloride or hydrated copper sulfate. But we know the color of this is blue. Okay, color of this is what? The color of copper sulfate is blue. Okay, and if you don't know the color of these two, so you don't even require this. But because we know in this Y is hydrated in nature. Okay, Y is hydrated in nature. That's why hydrated copper 2 sulfate, its color is blue. And if you don't know, so the color of this one is anhydrous cobalt 2 chloride. It's a blue color in the nature. And the color of this one, anhydrous copper 2 sulfate, it's a white in nature. Anhydrous means there is no water molecule. And hydrated cobalt 2 chloride is a pink solid. So when a Y is what? It's a hydrated cobalt 2 chloride. So when we heat it gently, it convert into blue, which is what? Which is this one, anhydrous cobalt 2 chloride. When we heat, so whatever the molecule of water present into this, it will every water molecules lose it, and it will convert into anhydrous. Now, what is the meaning of anhydrous? There is no water molecule present. So that why this is converted from pink to blue? Because of water molecules. So in this there was water molecules, so the color was pink, and after removing water molecules, the color become blue. And again, if I add water into this, it will convert into what? Pink. So overall, the answer of question number 15 is C. Now, when magnesium is added with zinc oxide in a reaction occurs of a reaction, zinc oxide, a reaction occurs. So reaction equation is shown. Magnesium plus zinc oxide here. Magnesium plus zinc oxide. So as you can see that magnesium is more reactive than zinc. According to our reactivity series, potassium. Okay, according to our reactivity series, potassium, sodium, calcium, magnesium, okay, aluminium, carbon. After that, zinc, Fa, hydrogen, copper, silver, gold. Okay, this is the reactivity series of elements, and the reactivity of series like this, from down to up it is increasing, or you can say from the up to bottom, from top to bottom reactivity of elements decreases. So here magnesium is more reactive than zinc. So that's why it can displace, because we know more reactive element can displace the less reactive element. So here Mg is more reactive than zinc, so it can easily replace zinc. So it will convert magnesium oxide and zinc. So now what is the oxidation? Which substance is oxidized here? So you can see magnesium is converting from 0 to 2 plus, and here 2 plus converting into 0. So when oxidation number increases, so from 0 to 2, oxidation number increases. So overall magnesium is oxidized here. Now question number 17, aqueous P, it's an aqueous P, and here a solid Q. Okay, a small volume of aqueous P is poured on a liquid Q, the tap of the funnel closed. Okay, after dropping 2 to 3 drops of aqueous P, we tap this, or we close this tap, and what will happen? Which pair of substances causes the syringe to fill up with gas? So in these, which of the pair will fill up this syringe by the gas? So when it will happen, some gas should be produced. So what are the pair? Nitric acid reacts with magnesium. Will it happen or not? Because you can see some cross nishine is also given here, cross cross cross. So they are saying that this reaction will done or not. So when magnesium is reacting with nitric acid, so how we will see this? Magnesium and nitric acid. So magnesium is more reactive than hydrogen also. In this you can see that magnesium is more reactive than hydrogen. Magnesium is above and hydrogen is here. So magnesium is more reactive than hydrogen. It can easily remove hydrogen and take the place of hydrogen. So magnesium nitrate and hydrogen gas removes. So yes, this is a gas. So when it will magnesium react with nitric chloric acid, so yeah, this syringe will be filled up by hydrogen gas. What will happen if we use copper and HCl? So as you can see that copper is below hydrogen, so copper cannot replace hydrogen, so no reaction. Copper is less reactive than hydrogen, so according to reactivity series, copper cannot displace hydrogen, so no reaction. So second one should be cross. Okay, this it should be cross. So option C is the correct answer for 17. Now we have question number 18. Part of the periodic table is shown, like this is periodic table, and some numbering 1, 2, 3, 4 is written here. So as we know, the left part of the periodic table is what? It's a metal only, and in right part, okay, in right part, it's like a structure, steer like structure, which is what? It's a metalloids, which have both property metals as well as non-metals, and below this only metals is present, and above this metalloid series only non-metals are present. So overall, what is the question? Which element forms basic oxide? So as I already told you that metal oxide forms basic oxides and non-metal oxides forms acetic oxide. So here we need basic oxide means we should have only metal oxides. So 1, 2 are the basic oxides. Now question number 19. Aqueous ammonium sulfate is made by reacting aqueous ammonia with dilute sulfuric acid. How is ammonium sulfate obtained from the resulting solution? So what will happen? See, we are preparing ammonium sulfate by using ammonia and hydrochloric acid. Ammonia and hydrochloric acid. So how we can get a solid ammonia, because initially we are having aqueous ammonium sulfate and we need solid ammonium sulfate. So for that, because we need to remove its water, so for that we will use crystallization process. Okay. 20. Which statement about periodic table is correct? So element in the same group have the same number of electron shell? No. Electron shell means number of electron shell going downward increases. Elements are arranged in order of increasing proton number. Yeah, this one is right. 20. Atoms are arranged according to their increasing proton numbers. Now 21. Part of the periodic table is shown which element conduct electricity. So electricity means atoms should be metals. So only this is a metal. All B, C, D are non-metals or maybe metalloids. Now 22. Some information about properties of group 1 elements are shown. Lithium has melting point 181 degrees Celsius, whereas its density is 0.53. Sodium has 98, its density is 0.97. Potassium should be less than the temperature required for sodium. So temperature, and we already know that its temperature is around 64 or you can say 63 also. So melting point of potassium is 63 or 64, and for rubidium it should be less than 64, so it should be 39. Okay, and you can see that the density is increasing. Okay, down the group density increases, so Z should be more than 0.97. So the value of Z should be more than 9.7, so it can be like this or this. Okay, but value of Y should be 93. Okay, because less than 63 or 64, so the only option is 39, which is this one, and the melting point of X is 63. Okay, so the correct answer for 22 is D. Now gas G has 10 electrons, whereas gas H has 8 more electrons than gas G. Both gases are monatomic. Means monatomic means they belongs to what? Noble gases, because 10 represent if gas G has 10 electrons means it is a neon gas, and if we are talking about 8 more electrons, which is equal to how much? 18. So 18 is what? 18 is argon. So if it is neon, second one is argon, second one is argon. So, and both are monoatomic, which means they do not react with others. Okay, which statement about G and H is correct? Both gases are in the same group of the periodic table. Same group of the periodic table. Yes. Both gases have the same period. No, this is not. Both are very reactive. No, this is not the one. G has. So you can directly say that A is the correct answer, because both are in the same group of the periodic table, which is group 8 or 18. 8 according to Mendeleev's periodic table and 18 according to modern periodic table. Now we will see 24. Metal M is placed between zinc and iron in the reactivity series. Which row shows the reactions of M and its oxide? So as you can see here, potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, Fe, hydrogen, copper. This. So we are saying that M is placed between zinc and Fe. Okay, zinc and Fe. Now M can be extracted. M can be extracted by heating its oxide with carbon. If I am having oxide of oxygen and I react this oxide of that metal with carbon. So you can see that carbon is more reactive than this one because M is between zinc and Fe. So you can see that M is less reactive than carbon. So carbon can easily replace this M and it will convert into metal, and maybe this product will be carbon monoxide or carbon dioxide. So yes, it can easily replace. What will be the final product? It is not necessary it will only form carbon dioxide or not, but it can easily extract. M can be extracted by heating its oxide with carbon. So the answer is yes. The answer is yes. Okay. M reacts with dilute hydrochloric acid. Now M is reacting with dilute chloric acid. So now this M is reacting with this. So yes, M can replace this because M is more reactive than hydrogen. So the answer is yes. But both should be yes, yes. So answer of 24 is D. Now 25th, which statement about sodium is correct? It is reactive grade solid which do not conduct electricity. No, sodium conduct electricity. It is very reactive element that forms ions with a single negative charge. No, it forms an ion with a positive single charge. It reacts slowly with water to form oxide. No, metals Na react with water to form NaOH and hydrogen gas. Now it reacts rapidly with water to form hydroxide. Yeah, D is the correct answer for 24. Iron from a blast furnace can be converted to steel. Which statement about steel are correct? So steel is made by mixture of iron plus carbon. Okay, mixture of iron plus carbon. So steel contains more carbon than the iron obtained from the blast furnace. Steel is produced by glowing oxygen through the oxygen. Okay, oxygen through the iron, and the calcium oxide is added to molten iron to remove basic oxides. So here, okay, we'll say this 24 or 27. Which row link a property of aluminium to its stated used? Now aluminium, it's a high strength, resistance to corrosion, okay, high density, good electrical conductivity. Okay, they have all the properties, but high density, no, it have low density, sorry, it's have low density, and manufacturing in aircraft, yeah, this is right, this is right, it is used in aircraft, but not for this. Like if it is a good conductor of electricity, that's why it is using it in aircraft, and it high density it is using in, no, it is low density, that's why it is used in aircraft. And the resistance to corrosion, that's why used in food container. Yeah, this option is the right one. Why it is used as a food container? Because it is resistance to the corrosion, it resists to corrosion. Now question number 28, the diagram shows a stage in the purification of dirty water. This is the dirty water. Now below dirty water sand is present, fine gravels, okay, and coarse gravels, and it is a what, this is a pot with holes in bottoms. Which process does this apparatus shows? So which process does this apparatus shows? So in this, what we are doing, we are doing filtration. Water is filtering from in this picture. Now question number 29, which substance is polluted air, damaged stonework and killed trees? So which polluted air, damaged stonework? It's a sulfur dioxide, SO2 is the one polluted gas which damages the stonework and kills the trees. Now question number 30, which reaction produce ammonia gas? So which reaction produce ammonia gas? So ammonium chloride reacting with sodium, dilute sodium hydroxide. This is ammonium chloride reacting with NaOH. So what will happen here? NaCl, okay, NaCl, ammonia and water molecule. So ammonia will form using first reaction. Okay, warming ammonium nitrate with dilute sulfuric acid. We can do this ammonium nitrate, ammonium and dilute sulfuric acid. So what will happen here? It is plus, it is minus. So nitrate sulfate, okay, ammonium nitrate, or ammonium sulfate, okay, ammonium sulfate plus nitric acid. Now, if we use ammonium phosphate and sodium chloride, ammonium phosphate and sodium chloride, so it will form sodium phosphate and ammonium chloride. Okay, and ammonium sulfate reacts with dilute chloric acid, dilute nitric acid. This will also not produce ammonia. Only option first will produce ammonia. Now, question number 31. Which reaction produce carbon dioxide? So in this addition of dilute nitric acid to a copper 2 carbonate, high zinc carbonate, heating zinc carbonate or combustion of methane. Yeah, combustion of methane produce carbon dioxide. Okay, heating of carbonate also produce carbon dioxide. Okay, if I have ZnCO3, so zinc oxide and carbon dioxide, so this will also produce carbon dioxide, and adding dilute nitric acid to a copper carbonate, CuCO3 reacting with HNO3. So what will be the product? product will be this one. Okay. It will produce CO2. So all the three options are the correct. Now question number 32. Which element has an oxide that is used as a food preservative? So sulfur is the element whose oxide is used as food preservative, which is sulfur dioxide. Which substance give off carbon dioxide on heating? So in all the three ones, which substance can give off carbon dioxide? So limestone is what? Limestone is what? It's a carbonates, calcium carbonate. So heating of calcium carbonate will give CO2, calcium oxide plus carbon dioxide. And this is what? It's a lime water. So it's calcium hydroxide, and slaked lime is the same thing, calcium hydroxide. And lime is what? Lime is calcium oxide. So the correct answer is 33B. Which formula represents ethanol? Ethanol means the carbon should be 2 and one OH should be present. So there should be 2 carbons. So 2 carbons, but no OH. 2 carbons, okay, OH. And here 2 carbons, but 2 OH is present here. So, and it is known as carboxylic acid group. It is known as carboxylic acid group. And your right answer for 34 is C. Now 35th, fuel oil and naphtha are two fractions obtained from petroleum. What are the major uses of these fractions? Fuel oil, jet fuel, ship fuel, ship fuel. Okay. 35. Which compound is a member of alkene homologous series? Which compound is alkene homologous series? So the formula for alkene should be what? N and double of this. So 2N, this 6 1. It should be 8 for alkene. It should be 2 or it should be 4, and it should be 16. But because they are alkenes, that's why 2 extra is in this and this. And for alkene, this is the homologous series. Now question number 37. Which type of covalent bond is found in both a molecule of methane and a molecule of ethane? So you can see that in methane only covalent bond between carbon and hydrogen. Common in both. So single bond between a carbon and a hydrogen. Double bond between this, no. It is present in ethane. It can be, no, there is no double bond, only single bonds. A single bond between a carbon and a hydrogen atom. Now, a question number 38. A large hydrocarbon undergoes cracking. So when these go under cracking, a small hydrocarbon X and a gas are the only two particles, and a gas are the only two particles. So only two particles are formed when hydrocarbons goes on cracking. Suppose if I have this a large number of hydrocarbons, and when I heat this, because it is cracking means heating, and it is converting into unsaturated or saturated. So this one is now saturated compound, alkane. And if I remove using heat, I remove two hydrogens, it will convert into saturation and hydrogen gas will be produced. So according to me, answer for 38 should be D, unsaturated. Okay, the compound X should be unsaturated and gas will be hydrogen. Now structure of two hydrocarbons M and N are shown. Now M is alkane. No, M is not alkane. M is alkene. Yes, M is alkene. Now N is alkane. Yes, N is alkane, but is not. So this one and this one is the wrong answer. Now decolorize the bromine. So in alkane, no reaction for decolorization. So the answer of 39 should be B. Now question number 40 and the last question of this paper. Some information about four substances PQRS is listed. Okay, PQRS is listed here. So P is made by combining many small molecules together, whereas molecule Q are the largest molecule found in petroleum, and R is produced by cracking alkanes, and S is already nylon. Which substance are synthetic polymers? So synthetic polymers, this is the example of synthetic polymers, and P is made by many molecules together. P is made by many, containing many small molecules together. So this one. I hope guys you understood this lecture very well. Okay. So you can subscribe our YouTube channel STEM Education, and thank you for watching our videos. Thank you guys.